Good evening. Hello, everyone. Another session. Today we're discussing module number 14, which is the transport layer. Um, this is another tricky, not as tricky as module 11, 12, but it gets quite a number of questions. Um, if you are to go all the way and do your certification, write your final exams, you definitely find the transport layer questions a bit tricky. Very tricky. So I think it's a very important module in CCNA, a very important layer as well in the OSI model, which is the transport layer. So today we basically look at the transport layer. Uh, Patakaita module 3, I think we just define the transport layer as a layer responsible for things like segmentation. That's how we defined it. Segmentation, breaking down messages, uh, then sequencing so that we can later on rearrange them. I think basically that is how we defined the roles that are played by the transport layer, breaking down the message. Here we go a little bit deep, and you will see it's not only breaking down the message that is done in the transport layer. We also have the transport layer acting an important role of enabling reliability in our communication, making sure that a message that is sent is received at the other end. The application is responsible for that, making sure messages are being sent to other devices. Right? It also acts as an intermediary which provides logical communication. Logical, it acts as a logical channel, if I can say. Um, with the physical layer, we have the physical media, which is used for transmission. Two devices connect using that physical medium. At the transport layer, we have a logical connection. There is a connection, it's logical. It's not there, it's not physical. But there is a connection which devices make at the transport layer, which allows them to communicate. It seems like they are connected physically, but they are not. We'll get to explain all of those things in today's lesson. Uh, let's get into it. All right, the module objective is to compare the operations of the transport layer protocols in supporting end-to-end communication, explaining the purpose of the transport layer, the characteristics of TCP and UDP, which are the two main protocols in layer 4, explaining how TCP and UDP uses port numbers, another very important function of the transport layer, making use of port numbers, explain how session establishment and termination processes facilitate reliable communication. We also look at explaining how protocol PDUs are transmitted and acknowledged to guarantee delivery. Compare the operations of the transport layer protocols in supporting end-to-end communication. Right. The transport layer is responsible for the logical communication between applications running on different hosts, the link between the application layer and the lower layers that are responsible for network transmission. So you can look at the transport layer as the layer which connects the upper layers, the application layers, and the lower layers from the network to the physical. I think there was a thing I talked about in terms of carriers. You see that guys which operate at the top of the transport layer, that is at the application layer. That is where your software engineers, your developers mainly operate above the transport layer. Then your network engineers, your telecom engineers, network technicians, they operate below the transport layer. So the transport layer is sort of that guy in the middle, the intermediary, acting as an intermediary layer which is responsible for transmission in our networks. Right, some of the key functions of this layer, we have number one, obviously segmentation, which is the one which we use to define it. We also have flow control. I think when you did the data link layer, layer two, we mentioned something to do with flow control. So at layer number two, we do have flow control, which is more limited to local networks, local area networks, right? Then we have at layer four, flow control as well, which can covers end to end, basically. Even if the device is remote, there is still need for flow control. So flow control for end-to-end connections, remote connections, layer four is responsible for that. It's there just for that. Then if you're in a local area network, layer two flow control and its protocols is more responsible for that. So I talked flow control. Um, there's also connection establishment and termination. We'll get to look at that in later slides. Multiplexing, demultiplexing, multiplexing, joining information. If you have multiple sessions running on an application, on a device, if I can say, multiple sessions running on a device, but you want to transmit them using probably one logical connection, how does it happen? That is what multiplexing is. The transport layer is responsible for that. I think we'll get to see a lot of that in the next slides as well. Transport layer responsibilities. So I think that was what I was going through. We have tracking individual conversations, segmenting data, reassembling segments, adding header information, identifying, separating, managing multiple conversations, using segmentation and multiplexing to enable different communication conversations to be interleaved on the same network. Number one, tracking individual conversations. What is that? So you realize that a host can have uh, multiple applications communicating across the network at the same time. Multiple applications. Let me see, where's my pen? Just a minute. Right. So I was going into tracking of individual conversation, and I was saying you realize that a host can have multiple applications that are running on a device simultaneously. For example, you can have right now on my device, I have Zoom. That's an application, right? I have WhatsApp, another application running. I have LinkedIn, LinkedIn, another application running. So these are multiple applications communicating simultaneously from this one device. Now, the transport layer, what it does, it treats every um, communication from these applications as an individual application. So Zoom, maybe it's communicating with the device one. WhatsApp, I'm communicating with device two. LinkedIn, I'm communicating with another server, server number three. So these are three different applications, but from the same device. What is responsible for separating these applications is the transport layer. So it's responsible for saying, okay, with Zoom, we are talking to device one. So every flow, every traffic that is coming from the Zoom application goes to application number one. There is no confusion. Some of the traffic from Zoom going to another device, another end device, number two in this case. So tracking individual conversations, the transport layer is responsible for separating distinctively this application is communicating with that other application. This one, that other application. Tracking of individual conversations. Right. Number two, uh, I think before we get there, the transport layer is also responsible for uh, maintaining multiple conversations. Maintaining multiple conversations. I think it's the same thing, tracking and maintaining these multiple conversations. I think I've explained this one. Ensuring data from different applications or processes on one device do not get mixed up, delivered to the correct destination. There is no mix up between traffic from different applications. That is what the transport layer is responsible for. One, tracking of individual conversations. Number two, uh, segmenting and reassembling. What is that? So you realize as well, most networks have uh, a huge amount of data that is being sent. Huge amounts of data use a lot of bandwidth in networks. So from the application layer, when we come from the application layer, what we only have is data. It's not broken down. Nothing has been broken down. It's data. It's just huge chunks of data. However, huge chunks of data, they have a problem with taking a lot of bandwidth. That's one. Uh, Another reason is if you are sending a huge chunk of data and it is not delivered, then you need to resend it again. Another huge chunk of data being sent. With the transport layer, that way it comes in. It breaks down that huge chunk of data, saving bandwidth because you're now sending small segments. At the same time, in terms of delivering, with introduction of sequencing, for example, it means you can only resend that segment which wasn't received instead of sending the whole thing. So instead of having you sending the whole packet as a whole, you just send a segment that did not reach the other end device. So with that said, you see that this layer is also responsible for segmenting data and reassembling. Reassembling, that's where sequencing is here. Segmenting, so you have a packet, it is broken down so that it can be transmitted. The reasons why it's broken down, it has to do with the bandwidth. It has to do with handling errors as well. It's much easier handling segments with respect to errors than handling huge chunks of data. Right, data from application layer is broken down into segments. We've gone through that. It is also broken down into what we call datagrams. Right. As we will move with our session today, you will realize we have mainly two protocols that we'll discuss, TCP and UDP. When data is broken down by TCP, it's called segments. So when I mention segments, I think that was the PDU we gave for the transport layer. Izvozvi zitakupinda transport layer chaizvo, you will realize we have segments or datagrams. So when I talk of segments, it means it's information which is working with the TCP protocol. When I talk of datagrams, it means we are working with the UDP protocol. All right, segments include sequence numbers. This one is more reliable. So this one, it has sequence numbers. I think we definitely discuss how sequence numbers later in the slides. It has sequence numbers. It ensures reliability. It also ensures ordered delivery. How does it ensure reliability? Um, Sequence numbers. So if you are sending, this is our data, we break it down like this. Then we number it 1, 2, 3, 4, 5, 6. It gets transmitted. We receive our data. We are trying to reassemble it. 1, 2, 4, 5, 6. We have a packet which is missing there. Packet number 3. What happens? There is acknowledgement which is sent back to this device that we do not have segment number 3. Then segment number 3 is sent back here, and we now have something that is complete. That is how TCP ensures reliability. Making use of sequence numbers, you know which segment is missing from your information. You request from the sender to resend that. Reliability. Then we have another thing that it does, order delivery. When we transmit these segments 1 through 6, you are not guaranteed that every packet will be received in order here. It might come like this: 1, 5, 6, 4, 3, 2. That is not ordered, right? TCP, making use of sequence numbers, will be able to order this information 2, 3, 4, 5, 6 like this. The same way it was being sent. That is what sequencing is. I think basically summarizing these functions: segmenting data and reassembling segments with datagrams. So this was with segmentation. So segmentation, it is sequencing. There is reliability, there is order delivery. With UDP, we do not have sequence numbers, meaning there is no reliability and there is no ordered delivery. Segments are arranged the way they have been received with UDP. So TCP, segments, sequence numbers, reliability, order delivery, the other one, complete opposite. Now, which protocol to use will depend with exactly the application that you want to have. If you want an application which needs reliability, then you definitely have to use TCP because that is a reliable protocol to use. With UDP, it's usually applications which require speed, because with having these sequence numbers, it means you have a lot of overhead on your traffic. It's heavy. There is overhead. But without sequence numbers, your traffic is light. It means it moves faster. The only problem is it is not reliable, but it is fast. So if you have an application that you want to use where reliability is not an issue, but you need quick transmission, then UDP is the protocol for you. If you need reliability, then you use TCP. All right, let's go to adding header information. Right, this one is very straightforward, I think. We did encapsulation. We said it's every layer, there is header information that is being added. With the transport layer, with the data link layer, it was mainly the MAC addresses, the source and MAC. With the layer 3, it was mainly the source and destination IP addresses. Then with layer 4, we have the source and destination ports. Header information. What header information do we have at layer number 4? So we have the port numbers. So source port number, and we have the destination port numbers. Then if we're using TCP, we have the sequence numbers. We also have acknowledgements. acknowledgement numbers. Uh, what else do we have? Error. There is information that is responsible for error check. In this layer, we call it checksum. I think we had some discussions in one of the checkpoints where we're saying there's error check at layer 2, which uses FCS, cyclic redundancy, CRC, right? Then there's error check at layer 3, which is called checksum, which uses the checksum value. There's also error check at layer 4, and it also uses checksum. So understanding the difference between all these types of error checks will be very important. Error check is there at layer 2, layer 3, and layer 4. But how do you differentiate it? Flow control is there at layer 2 and layer 4. But how do you differentiate it? It's also important because question time, exam time, I think this is the type of questions that you'll be getting. Assessing your understanding of the difference between the roles that are being played at each layer. Right, adding other information. So I think this is basically some of the information that is added: port numbers, sequence numbers, acknowledgement numbers, checksum values, all in the headers. Right, we go to identifying, separate, and manage multiple conversations. Right, with segmentation, uh, it introduces us to the concept of multiplexing. Uh, Multiplexing, which allows us to have multiple conversations sharing the same network resources. So I think I was saying we have Zoom, we have LinkedIn, we have WhatsApp on the same host. So these are multiple applications, but the resources they are sharing are for one device. So how is the traffic being moved from one device to another? By using the same set of resources. We have what we call multiplexing. Basically, it sums up this, and these are the same resources that we are using. These ones. Everything is multiplexed so that we can be able to use the same resources to send that information. What allows us to do this is the concept of breaking messages down, which is segmentation. That's one. We have segmentation. We also have the use of port numbers, which allows us to do that. The use of port numbers. So segmentation, breaking down the message plus port numbers allows us to multiplex our information. Then when we're on the other end, we have demultiplexing, where we separate all that information. How do we separate it? It's mostly making use of port numbers as well as IP addresses from layer 3 as well. I think we'll get to look at what we call a socket. How do we identify segments? We use the sockets, the port numbers, and obviously the sequencing in each and every segment. Right. Uses segmentation and multiplexing to enable different conversations to be interleaved. What does interleaved mean? Interleaved, one on top of the other. English. English, very difficult. Right, I think this one, it also speaks to that same thing, identifying, separating, managing multiple conversations, making use of multiplexing. I think interleaving is basically having information one after the other. If I can generalize, let me do this. Let's say we have our packet here, Zoom, segmented like this. So we have link also segmented like this. Then we have WhatsApp also segmented like this. Right. This one is using let's say port going on ports. Let's use 4000. This one is using port 5000. This one is using port 6000. How is this information transmitted? So probably using the same resources, what you will get will be something like this. Zoom, LinkedIn, K, or everything being in the same set of network resources. Let me see. D, W, S, not in order. So this one, port 4000, this one, 5000, this one, 4000, this one, K, 5000. So what is happening here is all this information from different application is being multiplexed using sequence numbers from the segmented information that we have, sequence numbers, port numbers, then everything in a single logical connection. This is a single logical connection. Instead of having multiple connections, single logical connection after multiplexing, then when we are on the other end, when we are receiving our devices, we start separating it. So this was from port number 50, port number 4000. What is the sequence number? Everything from port number 4000 here with their sequence numbers. That's how you identify and separate the information from one host to the other. It sounds a bit complex the way I'm explaining, but it's not that complex. Multiplexing. Responsibility of layer number 4. As you can see, it's getting more than segmentation now. We now have segmentation, we now have sequencing, we now have the use of port numbers, all explaining what happens in the transport layer. Let's pick up pace a little bit. The transport layer does not specify how delivery or transportation of the packets takes place. Transport layer protocol specify how to transfer messages between hosts and are responsible for managing the reliability requirements of conversations. The transport layer includes TCP and UDP. I think the important thing from this one, the introduction of these two protocols, TCP and UDP. What we have here, IP not specifying how delivery or transportation of packets takes place. I think this explains the advantage, the benefit of the layered model. You realize that most of the things that happen in one layer, the other layer probably does not understand what is happening in the other layer. For example, when we did layer 3 and layer 2, you realize that you have the LLC in layer 2 responsible for translating what is happening in layer 3. So that layer 1, which is the physical layer, irrespective of what type of medium that you have, it does not concern the type of protocol that you are using at layer number 3. Every layer is sort of insulated from the other layer. It should not affect, or what happens in one layer should not contribute to what is happening in the other layer. That is basically what is being explained with this first point. Then with the transport layer protocol specifying how to transfer messages between hosts and are responsible for managing reliability. I think we already explained that one. Reliability being ensured by making use of the sequencing. One, another concept we introduce of acknowledgements, sending acknowledgements. after you've received a message, you actually respond, I've received this message. That is what ensures reliability. If you don't get feedback, if the message has been received on the other end, then how will you know if it has been sent? There is no way of knowing. So acknowledgements plus sequencing offers what we call reliability with the TCP protocol. UDP, completely another case. Transmission control protocol. Right. Here we get introduced to TCP. TCP provides reliability, flow control, and its basic operations: number, track data segments, transmitted to a specific host from a specific application. Tracking. How does it do its tracking? Numbering. Acknowledge received data. That's where reliability comes in. Sending of acknowledgements. Retransmit any acknowledged data after you don't get an acknowledgement after a certain time. It means that information was not received on the other end. Then you need to resend. Sequence data that might arrive in the wrong order. We've already explained that one. Send data at an efficient rate that is acceptable by the receiver. That is flow control. I think we introduced briefly what flow control is. So these are some of the roles that are being played by TCP as a protocol, right? In order to maintain the state of a conversation, in order to also track information, TCP establishes a connection before any data is exchanged. TCP is called a connection. This is where what I wanted to look at, connection oriented. I think in a number of literatures, you realize TCP is called connection oriented protocol. UDP will be called connectionless protocol. Why is TCP called the connection-oriented protocol? The reason why is it establishes a connection before communication. If you look at this guy, if this guy wants to communicate with this server there, the first thing that it does, probably not the first, but one of the first things that it does is establishing a connection. So it sends a message. We have what we call the three-way handshake. You definitely be coming across this a lot. The three-way handshake, where two devices communicate. It's basically saying, I want to send information to you. Okay, I'm open to you sending information to me. Then I've begun sending my information. That is setting up a connection. So before any information is sent, this device knows and expects information from this device. That is what connection oriented means. Before any information is being sent, these two devices communicate to say we actually want to send information, therefore be ready. Some information is coming from me. There's a lot of information that is being shared in those messages in the three-way handshake. I think we'll look at this later in the slides. But I wanted to introduce these two things, these two protocols from the perspective of connection-oriented and connectionless. So this one, before communication, there is a connection between two devices, logical connection. However, with UDP, no connection at all. So if this PC wants to send information, this server will know when this information is at this port. connectionless protocol. With TCP, before information is being sent, this one already knows I'm going to be receiving information from this PC. The advantages of being a connection-oriented protocol is obviously reliability. There is reliability. Um, Having this three-way handshake allows devices to offer more reliability. More segments are delivered. TCP connection-oriented, UDP connectionless. Right, UDP, it provides the basic functions for delivering datagrams between the appropriate application with very little overhead and data checking. So this one, it doesn't do a lot. It just sends. You don't have to check anything. If we have errors, no, we just send. Very little overhead because we don't have a lot of information to put in the headers. There is no sequence numbers. There is no field for sequence numbers. There is no field for acknowledgement. Less overhead. Advantages, obviously, speed. It offers a lot of speed in transmission. UDP is a connectionless protocol. It is known as a best effort delivery protocol because there is no acknowledgement that data is received at the destination. Best effort. IP was also known as a best effort protocol, if you remember well, IP. It does not guarantee delivery. That is what best effort means. You definitely encounter a question, Vunza, what does best effort mean? What are the characteristics of IP? Best effort is the other one. Media dependence. Is it dependent? Media independent. There is one last one. I'll leave you to that one. 1 minute left. I'm stopping this one. We continue soon after.